All right, mine are separated out. They're the same questions though. So number 1 says find a third degree polynomial function f of x with real coefficients that have 3 and 2i as zeros. What does it mean to have a third degree polynomial?
An x to the third.
It means there's 3 zeros. It means x to the third. So when you, hopefully that's like a heads up, there's more than these two, okay? But also when you go to check your answer, you should be writing an x to the third as your first term. So if I have 3 and 2i as zeros, what else do you automatically know you have? Negative 2i. So I'd get x minus 3 and x minus 2i and x plus 2i. And then, again, I said it yesterday, but I would strongly recommend you multiplying out the ones that have i's first because these are conjugates. The I will cancel out, making the next part easier. So I would get x squared plus 2ix minus 2ix minus 4i squared. That I squared becomes a negative 1, so this becomes plus 4, and these cancel out. You can also use your a squared plus b squared shortcut, where a is what's on front of the x, or a would be the x, sorry, and then b would be the 2. So 2 squared would result in 4. And make sure that you do the plus there, okay? Then I'm going to not forget to bring down the x minus 3 because that's a mistake people make you don't want to do. And I'm going to do x times x to the second, which is x to the third, x times 4, negative 3x squared, negative 12. And you get x to the third minus 3x squared plus 4x minus 12. That is your function. It equals f of x, okay? And by looking at it, you can see that it has an x to the third. So if you forgot to multiply out the last one, hopefully it'd be a little bit of a red flag that you're not writing x to the third. Questions on that one? You can also factor by grouping on this one and check it and go back to the original question and see that it works. All right, number 2 says, what are the zeros of the function? So this is not quadratic, which means I can't use the quadratic formula, right? It's an x to the third. So if I have no idea where to start from, what do you have to do? Plus and minus last over first. Really, it's just last. 1 and 150. 2 and 75. 3 and 50. 4 does not go into it. 5, 30. 6 and 25. Thank you. 7 does not go into it. 8 does not go into it. 9 does not go into it. 10 and 15. And then 12, right? Nope, that's it. So that would be my whole possible bank. And then it says, and then obviously I have to try these out. But remember, we can use things like Descartes' rule to help us kind of narrow this down. If I were to count the sign changes, that's 1, that's 2. So there are 2 or 0 positive ones, positive real roots. If I check the negative, how many sign changes? 1, which means try your negatives this time instead of trying your positives. So if I tried negative 1, I have to add in the x squared term, so 0x squared, 1, 0, negative 11, 150. 1, negative 1, negative 1, 1, negative 10. Not going to happen. Go to the next one. 1, 0, negative 11, 150. Not going to happen. Go to the next one. Nope. Because that last number is so big, if you wanted to skip to ones that you know the multiples would be bigger, that might make sense too here. Here's the one that works. So negative 6 is my negative root. And then I'm going to take what's left here, x squared minus 6x plus 25. And I would try to factor it, but are there factors of 25 that sum to negative 6? No, which means you're going to do the quadratic. A is 1, B is negative 6, C is 25. So negative 6 would be positive 6, plus and minus the square root of b squared, or negative 6 squared minus 4, times a times c, all over 2 times a. 36 minus 100 over 2. 36 minus 100, negative 64 over 2. The negative is going to come out as an I, and what's the square root of 64? Good. Can I reduce 6 plus and minus 8i over 2? Yeah, this would be 3 and 4. So my two other roots are 3 plus 4i and 3 minus 4i. Now, it didn't say to write them as a product of linear factors, but let's say it had. I would then have to put them behind x. So this would be x plus 6, x minus 3 minus 4i, and x minus 3 plus 4i. So your quiz will ask you to do that with one of the questions. Just make sure you pay attention, okay? The zeros, roots, solutions are listed, negative 6, 3 plus 4i, 3 minus 4i. The linear factors are written in parentheses like that. Question. This is why there's only 4 questions on your quiz. Look how much work just went into that. There's only 4. Yeah. Only. All right, 3. You'd have to leave it blank to lose all the credit, right? Let's be honest. All right. 3 says. You don't. All right, so the last one says use the given 0 to find all the zeros of the function, right? So a couple of you started testing out the last and first, which will eventually work, but it certainly takes longer. When you're given a root, use the one you're given. If it was just a single root, then I would do synthetic division with that single root and find the remaining. When it's complex or it has an I on it, I know that this plus its conjugate is 0. So I already have the 2. So then I'm going to take these two, I'm going to put them behind x. So x minus a negative 3 becomes plus 3, but the negative also goes to the I, so it's minus I. And then same thing for the next one, it would be negative to both of these, so it would be x plus 3 plus I. The signs on the I terms should be opposite. That's how they're going to eventually cancel out. So if you go to like distribute and something, they're the same, something's wrong. Now I'm going to multiply it out. So x times 3, x times I, then 3 times x, then 3 times 3, then 3 times I, then I times x, then negative I times 3, then negative I times positive I, negative I squared. If you did that last step correctly, then all your i's should cancel out. So ix and negative ix, positive 3i, negative 3i, minus I squared. This would be minus negative 1, which actually becomes plus 1. I get x squared plus 3x, positive 9, positive 1, plus 10. So then that is a factor of my original. So I put that on the outside of my division bar, and I write in the rest. It's in order. There are no terms missing. So then it's first into first. This would be 4x, and I'd get 4x to the third plus 24x squared plus 40x. Change your signs. This cancels. Negative x squared minus 6x. Bring down the minus 10. Negative 1. Negative x squared minus 6x minus 10. Change your signs. And it should give you a 0 as a remainder because those are factors. So the last remaining factor is 4x minus 1. As a 0, that would be a positive 1/4. So I'd get positive 1/4, negative 3 minus I, and negative 3 plus I. Raise your hand if we got it right. Good. So again, if you did last over first, you would have had it up, ended up having a 1/4 on the outside, which gets harder. Yeah. Of synthetic division. That's fine. Just be careful because it gets confusing with your eyes. But yeah, you get it. Yeah. This one. So it's x minus that whole thing. And it's x minus the other one. So the negatives got just get distributed.
And then you just plug that in next time.
Once you get it multiplied out, then you divide with that.